everybody, I'm Miss Cooksey. Today we're going to be talking about the transformations of functions. So we're going to look at two different functions. The first is an absolute value function. So we know what absolute value is, but we've never actually seen it graphed. So we're going to get to see what it looks like graphed today, and we're going to see how it transforms. So how can we move that graph up, down, left, right, make it narrow, make it wide. Then we're going to do the exact same thing with a quadratic function, which is a function we have a little bit more familiarity with. So the first thing we're going to do is look at this equation. This is the vertex form of an absolute value function. So vertex form means it focuses on the vertex. So let's talk about that first. H and K, let's make this narrower. H and K are the vertex of this quadratic function, or of this absolute value function. So H and K. Now notice that this is a minus H. That means we have to change the sign of H when we're actually coming up with the vertex. H, being the x-coordinate, represents the horizontal shift of the function. K, which represents the y-coordinate, let's see if I can zoom in on this a little bit. Nope, oh, there it goes. Too much. K, which represents the y-coordinate, tells us the vertical shift. So we'll see what that means in a moment. So that's H and K of our basic absolute value function. A is going to be very similar to the A in a quadratic function. So when the absolute value of A is bigger than 1, it is going to act as a stretch. That means our graph is going to get taller and narrower. When A, the absolute value of A, is between 1 and 0, so when it's a fraction or a decimal, it is going to compress. So that means it gets a lot wider. When A is negative, it is going to be a vertical reflection. That just means it flips upside down. In an absolute value function, A is also the slope of our lines. Oops, not a slur, a slope. So we're going to look over here at something called the parent function. The parent function is the most basic version of this function. So the parent function has no shifts whatsoever. So let's start with the vertex. Well, here we're not subtracting anything or adding anything, which tells us that our vertex has to be 0, 0. Then I'll go 2 points out in either direction. So when x is negative 2, the absolute value of negative 2 is positive 2. When x is negative 1, the absolute value of negative 1 is 1. We're going to keep filling in our chart, and then we can graph. So negative 1, 1, negative 2, 2, 1, 1, 2, 2, and connect those dots. This is the parent function. So this is our most basic function, and our vertex is at 0, 0. Now we're going to look and see what happens when we add these shifts to the parent function. So here, in this example, I have y equals negative x minus the absolute value of x minus 2. Well, we know that our vertex is hk. So here, h is 2, k is 0 because we're not adding or subtracting anything. So let's go ahead and plug in that vertex, and then we'll look at 2 points in either direction. So 1, 0, and 3, 4. Well, if I substitute in 0, 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2, but then I'm negativing? I'm making that negative, so it's back to negative 2. Same thing with 1. 1 minus 2 is negative 1, but the absolute value makes it positive, but the negative side makes it negative. So I can go ahead and finish up this chart. So I have a point at 2, 0. Then I have a point at 1, negative 1, 0, negative 2, 3, negative 1, and 4, negative 2. So transformations from the parent function. Let's see how this changed from the parent function. Well, the first thing we notice is that it has that vertical reflection. Because the a value is negative, it flips over the x-axis. The next thing we notice is that the vertex shifted over twice. That is that horizontal shift. So when we write a transformations, we're going to write it moves right, 2, and it is a vertical reflection. Let's look at this next one. Here, there's nothing in each position, so we know that our x-coordinate for vertex is 0, y is -1, so our vertex is 0, -1. We're going to move 2 points in each direction. So if I substitute in -1, the absolute value of -1 is +1 times 2 is 2, -1 is 1. Same thing with -2, the absolute value of -2 is 2 times 2 is 4, -1 is 3. So I can go ahead and fill those in on the other side and graph my function. So I have -1, 1, -2, 3, 1, 1, and 2, 3. So my transformation here is that my vertex went down 1, and that my graph got narrower. It stretched. It got longer and skinnier. So we're going to go ahead and call that a stretch. Okay, now let's practice doing this with just the equation. So f of x equals 2x. The vertex here is 0, 0, because we have no written out h or k value. Transformation is 2. Well, 2 is greater than 1, so that is going to be a stretch. Because the vertex is 0, 0, there are no translations up, down, left, or right. Here again, my vertex is 0, 0, because there's no h or k. This time there's a negative on the outside, so we know that that is a vertical reflection. When a is negative, that's a vertical reflection. Here, there's finally an h value. Because this is -3, we always change the sign of h, so that's going to change to a +3. There is no visible k value, so we're going to write 0. So the vertex is 3, 0. Now we need to find the transformation. Well, we already know that we move right 3. Then we need to look at this a value. This is 1/2. 1/2 is a fraction, which means it's between 0 and 1. So that's going to tell us that our graph is going to compress. So if we imagine our parent function, we're going to go to the right 3 units, and then our graph is going to get wider because it compresses. It's as though you're squashing it. Final one, my vertex is going to be my hk. Remember, we have to change the sign of h because it's supposed to be minus in the original equation. So this would be -4, -2. My transformation is going to be left 4, down 2. That's because of the vertex. And then I'm going to look at my a value, which is 3. So that is going to be a stretch because that's bigger than 1. So this is how we identify the vertex and transformations of absolute value functions. We are going to do the exact same thing next with quadratic functions. So with our quadratic functions, everything works in the exact same way. If the absolute value of a is greater than 1, it's a stretch. If the absolute value of a is between 0 and 1, so it's a fraction or a decimal, it compresses. And if a is negative, it's a vertical reflection. H and k, again, are the vertex. Again, h represents the horizontal transformation. and K represents the vertical transformation. So let's look at this example here. F of x equals x minus 1 squared minus 3. Well, my vertex is 1, 3. And I need to find my transformation from the parent function. Well, the parent function for a quadratic is x squared, because this would be the same as saying x squared plus 0x plus 0. So my transformations from this parent function, the a value doesn't change, so I don't have to worry about the a's, but I'm going to move right 1 and up 3. So right 1, up 3, and then I can go ahead and graph my quadratic. Let's look at a couple more. We're not going to worry about graphing because I'm not going to ask you to graph digitally, but I am going to show you what it looks like. You're not going to have to duplicate it on your own, and we are going to write the vertex and the transformations. Notice that each of these examples already has the parent function drawn, so you'll really get a chance to see what those transformations look like. This is the parent function already drawn. So here the vertex is positive 2, negative 4, because remember, this is minus h, so we have to undo that minus sign, making this a positive 2. So 2, negative 4. My transformations are going to be right 2, down 4. So I'm going to take this function and I'm going to go right 2, down 4. And I'm going to go ahead and place the rest of my points. I know where to place my points because of that 1, 3, 5 rule we talked about in a previous video, in the Introduction to Quadratics video. So if you need more information on how to graph a quadratic, that might be where you go. So now you can see that my parent function moved right 2, down 4. Let's do this next one. Here my vertex is positive 1, because we changed the sign of the h. So we know that their transformations are right 1, up 1. Then I need to look at this negative 2. Well, it's negative, so it's going to be a vertical reflection. And it's a 2, so we know it's going to stretch. This is all of the information I'm going to ask you for on today's assignment, but I'm going to show you how I would graph it. So my new vertex is at 1, 1. I went right 1, up 1. I need to vertically reflect this and stretch it by a factor of 2. So I'm going to go ahead and make my new points. Next ones would be like way down here. So you can see from my new graph that I moved the vertex right 1, up 1. I flipped it upside down, that's the vertical reflection, and I made it narrower. Let's look at our last two examples. In this example, my vertex is negative 3, 0. Negative 3 because the h value is positive, so we have to change the sign, and 0 because we do not see a k value. This tells us that we're going to go left 3. We're not going to go up or down because of that 0. And the negative a tells us that we are going to have a vertical reflection. So I'm going to go ahead and graph my new function at negative 3, 0. And then I can graph my vertical reflection. Again, I am not going to ask you to graph this yourself. I just need you to be able to find the vertex and find the transformation. Last example. Here, there doesn't appear to be an h value, so we're going to go ahead and write in 0. Our k value is negative 3. So our transformation is going to be down 3. And then we have a 1/2 as our a. That tells us our graph is going to compress by a factor of 1/2. So to graph this, I'm going to start by moving my vertex down 3. And then I'm going to graph by a factor of 1/2. And you'll notice that my graph gets a lot wider. So In this video, we talked about how to use a vertex form to find the graph of an absolute value function and a quadratic function. We talked about how to find the vertex from both functions and how to identify the transformations. Thanks for watching. I hope this video was helpful. Make sure you press that subscribe button, particularly in my class, so you never miss a video, and I'll see you next time.